Alright, so why don't we get started? Because we're already running a little behind. So by the way, my name is Vinay Narayana, and I firstly apologize for the title of the slide. The titles are different, but the content is the same. It's been a few months since I wrote my abstract, and I found out just yesterday that the title was something old. So this is a more appropriate title for my presentation, but like I said, the content is the same. It's all about how to use machine learning, how to build machine learning as an engineering discipline. So let me give a brief introduction of myself before I dig into this. I run machine learning engineering at Levi Strauss and Company. I just joined them a few weeks ago. Prior to that, I was at Wayfair for about 4 years, running their big data engineering teams and then machine learning engineering team. Prior to that, I have a pretty heavy experience in software development, and that's where my interest in doing machine learning as an engineering discipline comes about. For this presentation, this is my agenda. I want to first talk about what is ML as an engineering discipline, what it actually means, right? And then talk about a few current challenges. And then I'm hoping when you go through these current challenges, you will probably align, or at least you will realize that it's probably an issue within your organization as well. What I talk about next is the crux of my presentation. I want to talk about what the vision should be for a maturing machine learning organization, and what is that execution strategy. If you research the web, everybody talks about the North Star. Nobody talks about how to actually get there, and that is what I'm going to try to talk about today. So I hope to give you all at least a strategy on how you could go about building a matured machine learning practice within your own companies. I'll talk briefly about the execution plan, and then we'll just wrap it up with a quick summary. I was told I have 40 minutes, but I'm going to try to finish sooner than that if I can. And I'll leave a few minutes towards the end for any questions as well. Firstly, what is ML? What is running ML as an engineering discipline really mean? Delivering business value with machine learning is not just about building a state-of-the-art model. It also involves building a integrated ML system that is able to operate continuously and reliably, and is also able to adapt swiftly to any business requirement changes. I'm sure all of you deal with the business requirements changing all the time, so you really need a system that is capable of adapting to those changes quickly. So what does that ML system really look like? There are various components that I want to go over. Firstly, any data science model will have some data that is required. So there's some data collection, processing, management of your features. Your system should have continuous integration and delivery, which is pretty fundamental and something that we borrowed from the software development lifecycle processes. ML systems are more advanced than a simple software development system, so you really want to invest your time in continuous training and potentially deployment as well. Continuous training is quite achievable, and we'll talk about that a little bit. Deployment probably is one of the tougher ones to achieve. You want to have a ML system which allows you to train and evaluate your models at scale. You want to be able to serve your models in either real-time or batch mode as quickly as possible. You want to be able to track your model metadata and artifacts. And then finally, you want to have the ability to continuously monitor both your data and model, and for drift, basically. So all of this put together is a integrated ML system, and this is what we should be aiming for when we say we have a mature ML organization. I've been to a few presentations today and yesterday, and I think many people have touched upon these current challenges, so I'm really going to zip through these. Most companies have multiple data science teams, and each of these teams is operating as a silo. So everybody tries to productionize their models in their own sweet way. There are really no standards or any straight code between these teams. That obviously, if you can imagine, causes a lot of redundancy. Lack of feature store, and that's another major problem. Lack of data availability SLOs. Even the large tech companies have issues with data, so that's not a problem, or that's not something new or not a surprise. Next, monitoring your data and model in production or test, having limited to no operational readiness for your models, and finally, any data science model requires building and delivering a data science model requires collaboration with lots of partner teams, and it's one of the most forgotten, if you will, aspect of building and delivering models. So let's talk about a vision that will excite your stakeholders, your scientists, your management, etc. As an MLOps organization, you want to be able to build and deliver a MLOps platform and tooling that enables your data scientists to do a bunch of things. One, have access to reliable data that comes with SLOs. You want to give them the ability to automate their model training, evaluation, and validation. You want to give them the ability to serve their models either in batch or real-time mode as quickly as possible and as easy as possible. And we'll talk about how we will do all that. I have a few architectural patterns to go over. You want to be able to continuously monitor your data and model for drift. You also want to be able to use a trigger-based mechanism for continuous training. So what I mean by that is there are quite a few data monitoring and model monitoring tools out there that continuously monitor them for you, and they're able to generate an alert or a message that you can put in your messaging platform that you can listen in on. And when your, let's say, a model performance degrades beyond a certain threshold, this consumer or the alert that you're listening on, you can use that for triggering a continuous training pipeline, right? Assuming that is automated as well. So in other words, what I'm really going after, if I have to give you an analogy, is that you want to build a ML factory where the data scientists bring their models, they put the model on the assembly line, and as the model goes through the various phases of development, they use various automated tools that are available on the assembly line to automate things, right? And eventually, you want to run some quality checks on your model, and then you productionize it. So that's what we are aiming for. Now, in order for us to achieve a vision like that, I believe there are 6 fundamental things that any organization needs to invest in. The very first one is MLOps transformation. You really want to standardize and streamline all your MLOps work. You need to have one way of productionizing your models. You need to have one way of monitoring your models, etc. Okay, we'll talk a little bit more about it. A couple of slides to talk through some of this. Then feature engineering. One of the more important aspects in again model development, in my opinion, is having a feature store from where you serve as well as train. I think the gentleman who was presenting earlier, he just talked about how there could be a skew. And I think he also mentioned how often the data in production is so different from training, right? So you really want to avoid that skew, you really want to remove that skew. And a centralized feature store will allow you in doing that. Data availability. Out of the 6 goals or 6 things that I have here, the most critical aspect or the most hardest thing to achieve is the data availability. You really want to work with your data engineering teams to treat their data as a product. And I'll talk about what it means in a few slides from now. But anyway, this is one place where you really don't have much control in a typical ML organization. You have to depend on some other data engineering team to give you the data, right? So that's where this becomes very difficult for us. And I'll talk about how we can go about changing that or at least implementing that as well. Next, data and model monitoring. We need to have comprehensive monitoring capabilities. Operational readiness, we want to have some standard ways of operationalizing our data science models. Before you move into production, you need to have some capabilities built and a standard build that you have to follow before you move into production. And after you move into production, you need to figure out what level of support you want to provide. And last but not the least is executing as a product team. Each data science team typically has 4 different work streams working together, as you might expect. One obviously is the scientist, second is engineers, third product managers, fourth analysts. All of them need to together work as one team against one OKR and deliver against it. So that's what this means. Well, let's talk a bit about the execution plan. So this is the reference architecture. Being in software development for too long, I believe in building simplistic reference architectures that give us the most bang for the buck, if you will. For me, in machine learning, the most critical aspect is having a feature store, bam in the middle, right? A feature store allows you to use it for both serving in a batch mode or in a real-time mode, right? So hopefully with a couple of lines of code. And then you also have various data sources. Every company has, several different data sources. You have a data warehouse, a cloud storage, Excel spreadsheets, you name it, streaming data, right? So you want to create a capability of ingesting all of this data into a feature store. And you use this feature store for all your serving and training needs. And this automatically removes the training and serving skew. Right? Next, if you look at the bottom of this slide, we need to have a workflow orchestration engine across the board. If you're building an ingestion pipeline, you use the same workflow orchestration tool. Something like Kubeflow. Kubeflow happens to be my favorite. And obviously then the continuous data quality and model monitoring. And another important aspect that I want you to observe in the slide is the feature engineering libraries. Those libraries are, the way you want to think about it is, you really want to abstract away your entire ML platform through a library. Nobody touches your platform components like the feature store or the workflow orchestration engine, etc. directly. The only way they access is through a shared library that your team is going to build. Just imagine what it can do from a standardization perspective. If you have a simple shared library, so if you want to ingest something into your feature store, you do that one way. If you want to create a CI/CD pipeline, you do it one way. If you want to schedule your pipeline to run, you do it one way. So everything is controlled through that shared library. If you have any security requirements within your organization, again, this shared library will help. And beyond that, if your organization, let's say, is on premises or it moves into cloud or vice versa, whatever the situation is, and you have to change the ML platform, the only place where you make those changes is the shared library. You don't make changes everywhere, right? So that's the power of investing in building a fully featured abstraction library. This is a next level of detail on how this whole thing works. So you have various data sources, streaming data, batch data, and maybe some other external source data as well. And then again, feature store is in the middle, and you interact with the feature store through the libraries. There's a feature discovery solution also that's available that allows you to discover features that one science team has created so other people can leverage it. You serve from this feature store in an online or an offline manner. You train from the same feature store. You also build your models using the data in the feature store, right? You're using probably a notebook or an IDE connected to this feature store. And obviously, you have a metadata store if you're interested, then obviously a model repo as well. Now let's talk about, that was all about ML transformation and how you want to think about these architectures, system designs, and how you want to implement that within your own organization. Now I want to talk about the remaining 5 aspects on what that execution plan looks like. Firstly, feature engineering. I think I beat up this to death. Having a feature store is important. I'll move on. From a data availability perspective, like I said earlier, treating data as a product is super critical. What it really means is the producers of data who are emitting the data, they actually own the data from the point of emitting to the point it is consumed by the downstream teams such as the data science team or the analyst team or whoever it may be. The idea is if they make any schema changes, if they're adding new columns or removing existing columns, etc., they should be able to communicate all of that to all their downstream customers with giving them enough notice so they can change their models or reports or whatever it is to align with the new changes in data. And you want to demand your data engineering teams to give you data that comes with SLOs. And SLOs, in case you're not aware, stands for service level objectives. And generally, 4 lines of data availability is pretty cool. 4 lines means that about 53 minutes per year, your data can be unavailable, just about 53 minutes. So that's a pretty high level of availability. And lastly, if you have event-based architectures or if you have streaming data, it's super important for you to invest time and effort into building these public topics. So think of a e-commerce company and you have an order. A order could be placed by a business to business. It could be placed by an end user like you and I. And this order could be have multiple items in it. This order could have a full supply chain behind it, like who's delivering and things like that. The point here is something like as fundamental as a order on an e-commerce website is used by numerous teams. Is used by personalization teams. It's used by supply chain teams, supply chain data science teams. Numerous organizations need this information about an order, and if all of it was available in a public topic, it will remove the redundancy that people have to build to get some of this information about orders within their various use cases. So using a public topic can really solve that problem very well. For data and model monitoring, there are quite a few tools out there, and I've actually used a couple. If you're interested, just ask me after. I'll talk through them. But you want to use a tool which has inbuilt unsupervised learning capability for learning your data and also detecting any anomalies in your data. So let's say, for example, you have way too many nulls than normal. You want to be alerted about that. Some of these tools also have capabilities where you can build some formulae on top of your features. So for example, if you have a person's height as a feature, a person's height can only range from, let's say, 0.5 feet to about 10 feet. If it is beyond this range, you want to be alerted. Your data is corrupted. So you want to have some of these capabilities. Similarly, model monitoring, you want to be able to track your model performance on an ongoing basis. From an operational readiness perspective, this happens to be one of my favorite topics. You really want to invest some time in building operational readiness, some standards that you have to set for your model before it goes into production. Often I see teams moving their models ad hoc into production. You really don't want to do that. You want to have a strategy around how you do it. And you can figure out what that works for your organization. A batch model may not need 24/7 support, whereas a real-time model that is serving search or recommendations on your e-commerce website might need 24/7 support. So you basically agree to all the support statements, all the monitoring, alerting ahead of time. If it's a real-time model, critical model, you want to also have instant management capabilities within your organization figured out as part of this operational readiness. And last one is the executing as a product team. You really want to build atomic teams or squads or pods, as they call it in different companies, depending on where you work, containing these 4 work streams that I alluded to earlier: scientists, product managers, analysts, and ML engineers. The success of this team really depends on defining each person's role very clearly during the various model lifecycle stages, right? So if it's a POC, it's a discovery stage, right? So product managers get very heavily involved during the discovery phase, while the other work streams are just supporting the product manager, or maybe they're doing something else during that time. But once the discovery phase is complete, you have to do a POC. So who takes the lead on doing that POC? After that, what else? If you're doing feature engineering or productionizing the model, etc., you basically clearly call out what each of these teams, each of these work streams within the squad work on. And then, as part of this team, you also give them a single OKR, objective and key result. So everybody rallies behind in achieving that. There should be no shame in having a scientist review their code from a machine learning engineer, and machine learning engineer taking help from a scientist in doing the feature engineering work within the squad, right? So people should be collaborating very closely, writing high quality code, have high code coverage, etc. And everybody, the team succeeds or fails by their ability to hit that OKR, right? So you recognize the team's performance. Just because the team has not met their OKR doesn't mean it's a failure. All I'm trying to say is you recognize the success or failure of the ability of the team to hit the OKR as a team and not by individual person or individual work stream. That will avoid these frequent finger pointing that tend to happen in a few organizations. So with that, I'll give probably a quick summary. Building and delivering a fully automated ML system is not trivial. It potentially could take multiple years. And it's a journey, like my presentation title says. And your journey really starts with getting a vision in place. So I shared a vision over here. You can use it for if you like, but you can also come up with your own vision that makes sense for your own organization and get your scientists and your own organization excited about that vision. And once you are able to sell your vision, the next idea would be to come up with a viable execution strategy and go after it. With some discipline and ruthless execution, I believe any organization can achieve building a mature ML system. And with that was my last slide.
Let's give it up for Vinay.